Hi everyone, here we are going to talk about a new type of theorem which is called as the reciprocity theorem. Okay, this is one of the most simplest theorems of all the theorems that you have studied so far. So according to this theorem, it states that in a linear active bilateral single source network, the ratio of excitation and response remains same when the positions of excitation and response are interchanged. This means that here let's look at the sentence again. In a linear means the values of the output changes in accordance to the values of the input. That's what linear means. Active means the circuit should have active elements. Okay, bilateral means the circuit should be able to be drawn on a paper. It means it should be a two-dimensional diagram. That's what bilateral means. So in a linear, active, a bilateral, single source network. Single source means the entire circuit should have only one source. It can either be a voltage source or a current source, but it should be only one source. Okay. The ratio of excitation and response remains the same. You see, in a what is the meaning of excitation and response? You just think in layman's term, you can think of excitation as input and response as the output. Okay, so the ratio of input and output remains the same when the position of input and output are interchanged. Okay, that is the meaning of excitation. So let's take the circuit. Okay, so in this circuit you can see that this circuit is having a voltage source over here, resistor, inductor, capacitor, and another resistor over here. And here this is the source. So this is called as the excitation. So excitation means the reason why this is the element or the reason why the circuit is being excited or energized, or from where it gets its energy. Right, so this is the excitation. So which means this is the only parameter over here that is able to change the values of current or voltage across other elements. That is why this is called as excitation. You see, suppose if I switch off the circuit, then there is no current or voltage across any element over here, right? But if I turn on this voltage source, then suddenly current will flow through all the resistors and capacitors and inductors, and also potential drop will also be developed across every element. So that is why this is called as the excitation. So this is what you call as excitation. And the response means the output, or the response means the reason or the effect of, the effect of creating an excitation is what you call as the response. And the response is the response of the circuit when it is excited. That is why, that is the meaning of response. So here, if you turn on this voltage source over here, then there is a current I in this circuit that flows through this resistor, right? So this current I is considered as the response, and this is called as the excitation. So according to reciprocity theorem, if you interchange the position of the voltage, if you interchange the position of the input and output, or if you interchange the position of the excitation and the response, then the value of the excitation and the response remains the same. That is what this term means. You see, look over here. Here in this branch we have the excitation, and in this branch we have the response, right? So in this branch, this is the excitation called as a voltage source, which is 5 angle 0. And in this branch we have there's a current called I, which is the current flowing in this branch, or current flowing through this 2 ohm resistor. Okay, so in that case, if I interchange the position of the excitation and the response, if I interchange the position, then this will become that the current through this branch will now become I, and the voltage in this branch will be having 5 angle 0 voltage source. See, now you see it is being interchanged. So according to reciprocity theorem, if you interchange the value, if you interchange the position of the response and the excitation, the ratio will be the same. Here it is 5 by I, here it is also 5 by I. So the ratio remains the same. In other words, the value will remain the same. Okay. So this theorem most probably will be asked not to find the value of any current or voltage or anything. This theorem is only being asked to prove that this theorem is correct. That is how the question will be asked. They'll ask you to verify the reciprocity theorem. Okay. Let's do the same question over here. Okay. Let's do the same question. Okay. Same question over here. Okay, find current I in the given network and verify reciprocity theorem. So here this is the current I. Okay, current I is the current through this branch. So what I'm going to do is, how I'm going to do this problem is that I will first find the value of I. Okay, you can use any method. You can use mesh analysis or node analysis or any method you want, and from there you find the value of I. And after finding the value of I, what you're going to do is you are going to draw the next circuit in which their position will be interchanged, and there also you will find the value of I. And what you're going to do is that current value and this current value should be the same. That is what we are going to prove in this problem. Okay, this is how the question will be asked for this theorem. As they'll ask you to find some kind of a current in a circuit that which you can apply using mesh analysis or node analysis, and then they will ask you to verify the reciprocity theorem. Okay, so let's do this question. So first, in this case, what I'm going to do is, this is the question, right? So this is case 1. Okay, case 1 is when this circuit, when the excitation and response are not interchanged, they are kept the way how it is. Okay, and then I'm find the value of my response or my current. So this is treated as the response and this is treated as the excitation. Remember, you can only apply reciprocity theorem only if the circuit is having only one source, either a voltage source or a current source. Okay, so this is the circuit. So my job is to find the value of I over here. So I will apply mesh analysis. So therefore this is mesh 1 and this is I1 and this is mesh 2. So therefore this is current I2, and now I'm going to apply the equation for mesh 1. That is equation for mesh 1 is I1 into, it's touching these two elements, right? So 1 plus j minus I2. I2 is negative and I2 is touching only this inductor over here. So therefore minus I2 into j is equal to, and this current I1 is leaving the positive terminal, right? It's leaving the positive, it's flowing from clockwise direction, which means in this branch it is flowing from bottom to top. So which means it is the current, the positive terminal of I1 is generating the positive terminal of 5, the positive terminal of the voltage source is generating current I1. So therefore it is plus 5, and this is this first equation. And now the equation for mesh 2, the equation for mesh 2, and here in this equation I1 is negative and I2 is positive, therefore minus I1 into, and it's touching only this inductor, so it is minus I1 into j plus I2 into, it is, here it is, let me see, here it is 1j minus 1j plus 2 is equal to, there is no voltage source over here, so it is equal to 0. Okay, or in other words, this is minus I1 into j plus I2 into 2, right? I2 into 2 is equal to 0. Okay, so therefore if I'm going to write in matrix form, it will become like this. That is, in matrix form, 1 plus j, and here it is minus j, here it is minus j, here it is 2. This is the first matrix, and the variables are I1 and I2 is equal to 5, 0. Okay, so this is the matrix form. Okay, so here what I'm going to do is I'm going to find the value of I. Okay, so what is I over here? I is the current through this branch, so it is flowing from bottom to top, sorry, it's flowing from top to bottom. Now what is the name of the current? That same current that is flowing through this branch is also called as I2, right? Which means I2 is the current that is flowing through this branch, which is also called as I, which means, in other words, what this means is that I is equal to I2, right? Which means if you want to find the value of I, all you need to do is simply find the value of I2, right? So I2 is, we just need to find only the value of I2 over here. Okay, so I2 is equal to the determinant of 1 plus j minus j, 1 plus j minus j, 5, 0 divided by, and the denominator is the coefficient determinant of the coefficient matrix, that is 1 plus j minus j, and here it is minus j2, minus j2. Okay, this is the equation for I2 or I, and this is equal to, let me see, so you will get minus or minus becomes plus, so this will becomes 5j by, and over here it is 2 into 1 plus j, 2 into 1 plus j, and here it is. Here it is j into j, minus j into minus j is minus 1. So minus and minus becomes plus. So this becomes plus 1. So we have over here as 5j by, here you have 2 plus 2j, 2 plus 2j, 2 plus 2j plus 1. Or in other words, we have 5j by 3 plus 2j, 5j by 3 plus 2j. This is the value of I2. 5j by 3 plus 2j. What's the value? 5j divided by 3 plus 2j, and you will get 5j by 3 plus 2j, and you will get 0.769 plus 1.154j, or in other words, it is option, let me find the polar form, it is 1.387 angle 56.310 degree amperes. So this is the value of the current I. Okay, so therefore this is the value of I2 is equal to I, so therefore this is the value of I. Okay, so I is equal to 1.387 angle 56.310 degree amperes, or it is also equal to 0.769 plus 1.154j, or it is also called as 5j by 3 plus 2j. This is the value of I. Okay, so now what I'm going to do is that I'm going to interchange the position of the excitation and the response, which means now my circuit will become like this. Okay, so voltage source, so this we'll short it over here. This is the resistor, this is the inductor, this is the capacitor, and now the voltage source, the resistor over here, and the voltage source. So now I changed the position of the voltage source and the response. This is 1 ohm, this is minus 1 j ohm, this is 1 j ohm, and this is 2 ohm. Okay, so now this is the voltage source, 5 angle 0 degree voltage source. Okay, so if this is, so now I interchange the position, so which means I interchange the position, which means this is the value of my current I. So now my current I is this one over here. Okay, so now what I'm going to do is that here I have found the value of I, but now in this circuit, in this circuit also I'm going to find the value of I, and I'm going to prove that both the values are the same. That is how we verify the reciprocity theorem. Okay, so first here also I'll apply mesh analysis. So this is mesh 1, so therefore this is I1, this is mesh 2, therefore this is I2. Okay, and so here in the circuit you can see that the value of I over here is equal to minus I1, right? Because I is flowing from top to bottom, whereas I is flowing from top to bottom, whereas I1 is flowing from bottom to top, which means in this branch the same current is flowing in the opposite direction, right? Same currents are flowing in the opposite direction. Therefore I is equal to minus I1, which means if you want to find the value of I here, you would need to find the value of I1, and then you just need to put a minus sign in front of it. Okay, so here equation for mesh 1, here the equation of mesh 1 is I1 into, and here you have 1 plus j, I1 into 1 plus j minus I2 into j is equal to 0. And now the equation for mesh 2, it is minus I1 into j, okay, minus I1 into j plus I2 into 1j, and minus 1j will cancel each other, only 2 remains. So I2 into 2 is equal to, and what about the voltage source? This I2 current is flowing into the positive terminal, right? This I2 current is flowing into this, flowing from top to bottom. So it is flowing into the positive terminal, which means this positive terminal is not generating I2, it is opposing I2. So therefore it is minus 5. Now I'm going to write this in matrix form. It will become 1 plus j minus j. Here it is minus j, and here it is 2, and here it is I1. The variables I1 and I2 is equal to 0 minus 5. Okay, so here we need to find the value of I, or I is equal to minus I1, which means from here we just simply need to find the value of I1. Okay, and then finally put a negative sign over here to find the value of I. So the value of I1 over here is Okay, and here you have minus 5j by, and here you have 2 into 1 plus j, and this is again plus 1. Okay, so in that case I can say that I1 is equal to minus 5j by 2 plus 2j plus 1, which is 3 plus 2j. 3 plus 2j. Therefore, value of I1 is equal to minus 5j by 3 plus 2j. Therefore, I is equal to minus I1, which is equal to minus of minus becomes plus. So, therefore, I is equal to 5j by 3 plus 2j. I is equal to, which means the value of I in case 1 is the same. Here the value of I is 5j by 3 plus 2j, and here also the value of I is again 5j by 3 plus 2j, right? Both of them have the same values, which means 5j by 3 plus 2j is 0.769 plus 1.154j, or it is also equal to 1.387 angle 56.310 degree amperes. So therefore, in both the cases, the value of I is the same. That is, the value of I in the circuit. In this circuit, this is the value of I over here in this branch, and by applying mesh analysis, I found the value of I, which is this value, and then in here also, when I am applying mesh analysis, this is my I. So when I am applying mesh analysis and when I found the value of I found that the same value over here. Both of them are having the same value. Okay, so therefore, hence the reciprocity theorem is verified. Okay, this is how we do the problem related to this theorem.